In this video, we're going to be taking a look at the D1 Pro, which is a premium desktop laser cutter and engraver from XTOOL. So big shout out to XTOOL for sending me this thing to play around with. And we've got a lot to go through here. It's going to be a very thorough video. I'm going to show you guys how to get set up and started with this thing. We're going to go through the full assembly process, and I have some tips and tricks for you guys through there that you won't find in the instruction manual. So let's not waste any more time and let's get started. Starting with the unboxing, the D1 Pro looks to be very well packaged. And the first thing you're greeted with here are these nice little cases that hold the instruction manual, as well as a set of sample materials to get you started. While the extra packaging is probably not necessary, it definitely contributes to having a higher end feel to the unboxing experience with a higher caliber machine like this. Once you pull back that top layer of foam, you reveal these beautifully anodized frame components. Now, I'm definitely a sucker for anodized aluminum, and when I saw this kit in red, it just blew me away. It's absolutely gorgeous. Having worked with a lot of cheap 3D printers and cheap laser cutters, I've definitely gotten used to the very inexpensive aluminum extrusion construction of most of those machines. I thought it was really nice to see that XTOOL took a different approach with their own custom profiles, and they didn't go for the typical plastic V-wheels on the aforementioned aluminum extrusion. All of the components look and feel really high-end, even down to the safety glasses, which come in a nice hard shell case. I was sent the 10-watt kit, so you just saw me pull out the 10-watt laser module. There's a few other frame components left in the unboxing here, the power supply, and finally a few odds and ends. Now we can get to the assembly, and although the included instruction manual is pretty good, there are a few small details missing that I'll walk you guys through. And so you can see I've laid out the frame components, and I'm going to be using the included screwdriver along with the M4x16 flathead screws to begin assembling these frame components into a simple box configuration. Each corner of the frame gets 4 of these M4x16 flathead screws, and I simply just start with the one on top so that I can get all of the corners aligned, and then I'll put in the other 3 screws at each of the 4 corners. When you're finished, each of those 4 corners will look like this with 4 of those flathead screws. Then you'll take 2 of the M4x25 flathead screws, and those will be inserted through the back of the frame, so you can see that I've flipped the machine around, and those will thread into the tensioners for the belts. On one side of the machine, you'll notice that the tensioner is loose, and on the other side of the machine, you'll see that the tensioner and the belt has come pre-tensioned. Next, we'll install the Y-axis pulley shaft, and the one end of the shaft has the tooth pulley pre-installed, and the other end of the shaft is going to need this split collar. The split section of the collar has 2 unequal length sides, but I'm pretty sure it won't matter which side you align with the motor and the other side with the shaft. The rod will get installed inside of the front frame member, and on the one side under the control board you can see a bearing, and on the other side that is where the Y-axis stepper motor resides. You'll need to untangle the untensioned belt until that carriage moves smoothly, and then you can wrap the belt around the tooth section of the pulley and insert the exposed end of the shaft into that bearing underneath the control board. If the belt is too tight, reach around to the back of the machine and loosen off the tensioner. Then you can align the pulley shaft with the stepper motor shaft and slide the collar down so it covers both of them. Do not tighten the screws on the collar just yet, and that's because we need to align the 2 Y-axis carriages. Now, the instruction manual tells you to move the 2 carriages to the front of the machine to get them aligned and bottom them out on the front frame member. Now, on the left-hand side, it will bottom out, but on the right-hand side, what I found is that the carriage will not bottom out. It actually touches a part of this PCB first. That means that your gantry would be skewed if you did it this way. So instead, we're going to move the 2 to the rear of the machine. And so here you can see that I'm going to get these 2 gold-colored carriages touching the back frame member. On the side with the untensioned belt, you may have to play around a little bit with the belt tensioner to get that carriage to completely bottom out on the back of the frame. Next, make sure the pulley and the shaft are pushed all the way over to the side of the machine with the bearing, and that's going to make sure your belt is aligned. And now we're going to take a look at this split collar a little closer. Now this is a very small detail, but I do feel it's important to do this correctly so that it prevents any future slipping between the stepper motor shaft and the pulley shaft. And so you can see when I move the collar back and forth, if you look very closely into that split section, you'll find that there is a point where the split section aligns with the gap between the pulley shaft and the stepper motor shaft. This is where you want this collar positioned when you go to tighten down those screws, and that's just going to ensure that both the shaft of the stepper motor and the pulley shaft are properly clamped down. Double check that the left and right hand side carriages are still bottomed out on the back of the frame and that they haven't moved, and then return to the collar and tighten the 2 screws down on the collar to lock the position of the 2 carriages in place relative to one another so that they are now synchronized in the exact same position. This will ensure your gantry, when you go to install it, is now square with the frame of the machine and it's not skewed. Now you can double check the tension on the belts and use these screws on the side of the machine to lock the tensioners in place so that they do not loosen off with any vibrations. Next, you can install the Y-axis stepper motor cable, and just take note that the 2 ends of the cable are different. One end will plug into the control board and the other end will plug into the Y-axis stepper motor. There are holes in the bottom of the front frame member intended for zip ties, so you can just tie that little cable up and out of the way. The gantry assembly is next, and what you want to do is use some side cutters to free up all the cables from the white zip ties, but at this point do not cut any of the black zip ties. Take a look over on the stepper motor side and there should be a cable and connector tucked into the belt, and that can get plugged directly into the X-axis stepper motor. Now take the entire gantry assembly, push the cables aside, and line up the 2 ends of the gantry with your Y-axis carriages. There are 4 M4x16 flathead screws that will be used to secure the gantry to those Y carriage brackets. Tighten down all 4 of those screws, and then on the left hand side of the machine on that carriage, there is a space for another flathead screw. You will use one M4x25 flathead screw, and that is going to be responsible for the belt tensioner for the X-axis. In your kit, you'll find a small jumper cable, and that's going to go between these 2 limit switches, one for the X-axis and one for the Y-axis, and you'll see here that I have the machine flipped upside down to better access these plugs. And while we have the machine upside down, it's a good time to make these other color-coded connections to the main control board. So these connectors here are coming off of the gantry, and there's a red, yellow, and white, and as I said, they're color-coded to connectors on the main board, so it's pretty easy to figure out where those will go to. The instruction manual and other YouTube tutorials I've seen tell you to tie up the X gantry cables using the holes in the side frame member. The problem with doing it this way is that when the X gantry moves, these cables will flex and they'll end up encroaching on the workspace, and inevitably they're going to run into your workpiece. I have a better solution, so this is going to be temporary to get these wires out of the way while we complete the rest of the mechanical build, and then we're going to get a little deeper into the wire management to improve things. And so one of the last pieces of the mechanical puzzle is the laser head module itself, and this is the 10-watt model. So what I'm going to do here is insert and install the air assist fitting. It should just screw into place, and then I'm going to be using, I believe this is an 8mm wrench, to lightly tighten it down. Don't go overboard here, you're just tightening this thing into aluminum, and the fitting is a swivel fitting, so you can just swivel it towards the top. And although I'm not going to be using an air assist on this machine, I'm putting this into place and showing you guys how to install it. The laser module installs onto the carriage using this dovetail style joint, and you might find that the retaining screw is a little too loose or perhaps a little too tight depending on how it was installed at the factory. Due to clearance issues, you can't continuously just rotate the screw around to adjust it. You have to rotate it a little bit and then pull out on this spring-loaded thumb screw style adapter piece. The thumb screw piece can then be repositioned, popped back into place, and then you can do another partial rotation. You might have to do this several times before being able to get the laser head module to slide down into place, In my case, the screw was too tight, so I had to loosen it off a whole bunch of times before I could get the laser module to slide all the way down. Then I had to work in the opposite direction where I had to make adjustments so that it was slightly tighter and find that next sweet spot where the thumb screw adapter at the top would allow me to move the laser head module around, and then when it was rotated down to the bottom, it was tight enough that the module would not move around. Once that was done, I was able to grab the last connector off the back of the gantry and install it into the back of the laser head and also through the strain relief at the back of that module. Now we're almost done, and so one of the final things to do here is insert the SD card, and now we can circle back to the wire management. We're going to spend some extra time on the wire management and address some of the issues that I've identified. The first one is with this little trigger mechanism for the optical sensors on the X carriage. With the cables in place as they were installed from the factory, when you move the X carriage back and forth, oftentimes that little trigger mechanism will catch those cables and start to drag them. Then the X carriage will bind. To fix this, we need to reposition these cables, and so you're going to remove those black zip ties all across the bottom of the X gantry. The cables should be repositioned from the bottom of the gantry to the back edge of the gantry. You'll also notice that I've repositioned the ratcheting part of the zip tie to that back edge, and that's going to get everything up and out of the way of that trigger mechanism for the optical sensors. Run the carriage back and forth by hand and make sure that you don't have any interference and it's not catching any of the cables. Now I've cut off the zip ties that were holding the cable set going back to the main board through those holes in the side frame rail. The original positioning of this cable will cause the looped end to bend towards the middle of your work area as the X gantry moves back and forth. The cable could then come in contact with your workpiece and potentially shift it around. Now, I'm not the first person to identify this issue. I've seen it in other YouTube videos. Some people have solved the problem with things like cable chains, but I have a much simpler, much faster, and lower cost solution, and we're going to be fixing the cable to the bottom of the frame member rather than the side. And we're going to be using these small adhesive cable clips. In order for them to properly stick, you're just going to grab some isopropyl alcohol and clean the bottom surface of this frame member. Then you can remove the adhesive backing and stick about 4 or 5 of them down on the bottom of the frame member. Do not put any past that last hole that was originally used for the zip ties. And if you guys are looking for these exact cable clips, I'll put a link down in the video description to where you can find them. Zip ties just loop through these clips and secure the cable to the bottom rather than the inside edge of that frame member. This minor change to the cable position completely changes the way that the cable behaves when it bends, and it stays completely out of your workspace. And the last issue that I found was that when you try to move the gantry to the very back position, sometimes that cable loop will get pinched between the gantry and the rear frame member. This can cause an unpredictable and slightly erratic movement of the gantry, and so to fix that, it's actually pretty simple. You can take one zip tie and secure the gantry wiring harness to the stepper motor. To do this, you're going to want to remove the plug from the stepper motor, and then it's much easier to wrap that zip tie around and get the cable flat against the stepper motor, and then you can plug the connector back in. When the gantry moves back and forth, the wiring harness will still bend with a nice generous radius in the loop, and at the very back of the gantry movement, you will no longer have that impingement between the gantry wiring harness and the back of the frame. If you watch carefully in this clip here, you can see that the movement is now smooth, and we've solved the issue without having to resort to expensive and complicated cable chains. That wraps up the assembly portion of the XTOOL D1 Pro, so take a moment to admire its beauty, because it's not often that you can actually describe a tool as beautiful, at least not from my experience. The red and gold is extremely striking, but keep in mind that this kit also comes in a gunmetal gray if you're a person who wants something a little more muted. If you've watched some of my other videos, you know that it doesn't take me very long before I start modifying my tools, and the D1 Pro is no different. I recently tested out another open frame laser cutter, and like everyone else who's ever used one, you come to realize that you need to find a way to manage the smoke and the fumes. So before even making any cuts, I got to work designing a new fume extractor for the D1 Pro. Now I'm not sure if this will fit the 20 watt module because I don't have one. This is the 10 watt module, and to install it, you can start by removing the fan guard at the top of the laser module. The 4 screws get removed and this whole piece gets replaced with a new fume extractor. The original hardware will be reused to secure the new piece in place, and this new fume extractor nozzle will extend down and beside the air assist fitting. It will not interfere with the air assist hose or fitting if you're running one. The concept here is to suck up the fumes and smoke right at the source, and this way you don't need a large filtration system where you're exchanging all of the air either inside of an enclosure or your entire room. In a previous video, I built a light-duty fume filtration system using a shop vac and some other inexpensive parts. I'll put a link to that in the top right-hand corner of the screen, and this should work very well with this setup here. The hose adapter at the top of this extraction nozzle is intended for a CPAP hose. I'll put a link to this exact hose in the video description down below, and keep in mind that if you guys are looking for one of these extraction systems, I'm going to make those available on my website, embracemaking.com. I would really appreciate it if you guys took a moment to check that website out, because that's where I put all of the upgrades I make available for machines like this, as well as 3D printers and other maker tools. It's part of how I fund this YouTube channel, and it affords me to bring this kind of content to you guys that I hope you're finding useful and informative. In order to make our first cuts, we need to get this thing up and running. So you're going to need to plug in the power connector as well as the USB cable, and then switch the power switch on, and the LED on the top of the unit should turn on. You should also notice the crosshairs on the laser module turn on. The other end of the USB cable will get plugged into your computer, and you're going to need to download the XTOOL Creative Space software. When you plug the D1 Pro into your computer, you will notice that some of the drivers automatically installed. However, when I launched the software, I did get this message that more drivers need to be installed, so I hit yes and installed those. On the top right hand corner of the screen, you can just click on Connect a Device, click on the D1 Pro, and if this is the first time turning it on, you'll likely have to update the firmware. Make sure the small dip switch on the side of the control board is in the correct position for a firmware update, and the XTOOL Creative Space software will take care of the rest. After the firmware update, don't forget to flip the dip switch back, and then in the top right hand corner of the screen, you can dive into the settings and we can set up the Wi-Fi connection. So you can do this as an alternative to connect to the laser cutter instead of using the USB cable. With the Wi-Fi SSID and password set, you can now unplug your USB cable. The software will automatically disconnect. You can go back up to Connect Device, head to the Wi-Fi tab, and then you can find your machine in the Wi-Fi tab. Once you click connect, you should see that your machine is now successfully connected through Wi-Fi. So it's important to note here that the XTOOL machine is compatible with the very popular Lightburn software, but I don't have a license for that. And considering this is an XTOOL product, we might as well see how their machine works with the native software. It has quite a few features, and I could likely do an entire video on XTOOL Creative Space all on its own. So really what I want to do here is just get right into the fundamentals of the software so you guys can get working right away. And the first thing you need to understand here is that at the time of the making of this video, the XTOOL software here does not support absolute coordinates. So what you're looking at is the usable space of your laser cutter. Therefore, when I click on the image button on the left-hand side of the screen and I import an image that we're going to engrave onto some wood, I can position this image anywhere within this usable workspace, but the position of the image within this workspace is not representative of where the tool head is going to move to engrave that pattern. And so for instance, I can move this image to the bottom right hand corner of this grid, and then when I head on over and I click the process button, you'll see here that all that shows up is the image itself, and there's a small green dot in the left top hand corner of this image, and this represents the 0 position or the origin position of the tool head with respect to just this image. Now I can change that origin position by clicking these buttons over here, and I can move that to the center, top right hand corner, it doesn't matter. That's just going to help me align the start position of my laser module with respect to my workpiece. Now I like using the bottom left-hand corner of my workpiece as my origin position, and as you'll see in this next clip, when I go to start and process the job, I actually have the workpiece positioned right in the center of my machine. And so even though that image, as I had said before, was set up in the bottom right-hand corner of that grid within XTOOL Creative Space, my workpiece is right in the middle. Again, we are not using absolute coordinates. This is all relative. I'm hoping that in future versions of the software, absolute positioning is supported because the D1 Pro does come with limit switches. So in theory, the machine could know its origin position with respect to its machine limits because it can home itself to those limit switches. This would make repositioning the tool head very easy, convenient, and highly repeatable. And so XTOOL, if you're listening, please make this available in future versions of the Creative Space software. Now, while this job is processing, I want to point out a few things. And the first thing here is that the fume extraction nozzle that you see in this first job is different than the one that I presented to you guys earlier. And that's because this is one of my earlier prototypes of which I improved the design. The second thing to note here is that I have the aluminum sheet underneath the workpiece. And now I'm not making any through cuts, I'm just engraving right now. I will be making through cuts in a moment, and when I do that, this is going to protect the table underneath. Unfortunately, this sheet is not all that big, and it's not very flat. You can see that it's quite thin and the front edge is lifting, and this is going to have an effect on the height of your workpiece relative to the laser. Therefore, your laser may not necessarily be optimally focused with respect to your workpiece. The third thing I want to point out is the silicone mat underneath the aluminum sheet. As you can see, it takes up most of the usable workspace, and this is an extra added layer of protection. In a moment, I'm going to process another job where I'm going to forego using the aluminum sheet underneath the piece of wood, and I'm going to be performing some through cuts. Ideally, you would want something under the workpiece when making those through cuts to provide some sort of air gap between the bottom of your workpiece and the silicone mat. However, in the next example, I'm not going to do that, just to demonstrate how the silicone mat can absorb the 10-watt laser module set at 100% power, and it still won't burn through that mat, and it will save your table. And so if you're looking for one of these silicone mats, check the video description down below. I'll put a link to it down there. Occasionally, I'll see people using those self-healing cutting mats, and I would highly recommend not doing this because oftentimes those contain PVC, which is extremely dangerous to cut on a laser cutter. But back to this example, you can see that the tool head is now running the through cut with the aluminum underneath, and we'll see how that turns out. With the job done, I can tell right away that I need to fine tune some of my settings, and I just used some of the presets in the XTOOL Creative Space software for 3mm thick basswood. The presets are always a good starting point, but I can definitely see that the power settings are a little too aggressive, or alternatively I could leave the power settings and I could speed up the tool head movement a little bit. That will likely give me much crisper results for the engraving, and for the through cuts I'll probably have a lot less burning. However, in this particular case, because I had the material sitting right on top of that aluminum sheet, a lot of the burning that you see along that back face is probably due to some amount of reflection of the laser. And this is where I was saying earlier that it is ideal to have some sort of airspace beneath this piece, and you'd want to use some sort of grid-like material to support the workpiece so the laser can pierce right through and not be reflected back at the bottom surface of your wood. Now in this next example, I'll be a little more thorough in walking you through the entire process start to finish of engraving and cutting something. And so I've imported a PNG file here through the image button on the left-hand side of the screen. And this is basically what's known as a rasterized image, and it has no vector components to it. And therefore, when you click on it on the right-hand side of the screen, you'll see that the only option is to engrave. Now there are ways to convert certain parts of the image and create outlines and make vector components out of something like this, but that's outside of the scope of this video. And so right now I'm just going to show you with this rasterized image. You can head on over to the right hand side of the screen. Like I said, you're just going to be able to engrave. I'm going to select a preset, so I'm going to select the 3mm basswood plywood, And then from there are power and speed settings, but again, those are parts of the presets that are all selected for you. So you can just go down and hit process. I'm going to set my origin to the bottom left-hand corner of this image, and then I'm going to hit the button that says framing. A prompt will appear telling you that the machine is ready for framing, and all you need to do is hit the button on the front of the machine. Over at the D1 Pro, before doing any framing, I want to make sure the laser is focused, so I have to set the tool head height. I'll flip up the thumb screw retainer on the left-hand side. I'm going to flip down the focus bar on the right-hand side. That focus bar will touch the top of my workpiece, and then I can flip the thumb screw down on the left-hand side, tightening and securing the tool head in place, and then I can flip the focus bar up on the right-hand side, up and out of the way. And now the tool head height or laser focus has been set. But now we need to set the X and Y position. And so as I discussed before, the machine is not using absolute positioning, it's using relative positioning. And so you'll see that I have the crosshairs set up at the bottom left-hand corner of my workpiece. You'll notice that the crosshairs are offset from the center of the laser, mostly just in the X direction, but the software compensates for this offset automatically and you don't have to do anything about it. Just line up the crosshairs in the bottom left-hand corner of your workpiece and make sure your workpiece is square within the frame. The front button of the machine is outside of the frame of this shot, but I just pressed that button and the machine did the framing. What this does is it moves the tool head around the outer limits of the file that you're about to process, and this gives you some sort of visual indication of the bounds of the toolpath. This also ensures that you've positioned the workpiece in a place where the toolpath will not exceed the bounds of the machine. And so if it tries to move to a place where it's going to trip a limit switch, the machine will trigger an audible alarm and you'll know that you'll have to reposition your workpiece. In this case, everything looks good, so I can click on framing completed, and then I can go up to the right-hand side of the screen and click start to start the job. A prompt will appear telling you to press the button on the front of the machine to actually start the job. The engraving job will now begin, and I've sped this video clip up about 3 times, so it's not so painful to watch, but what you'll notice here is that I do have the new vacuum extraction nozzle mounted to the tool head, and it's doing an excellent job of removing all of the smoke and fumes. As you can see, there's no accumulation of smoke in the work area. It's all being extracted right from the source with that nozzle. And if you guys want to grab one of those for your XTOOL D1 Pro, check out my website, embracemaking.com. I'll put a link to that product down in the video description below. When the job is complete, the tool head will return to the origin position and will be ready for the next process, which will be the through cuts. Under normal circumstances, I would have processed the engraving and through cuts all in one shot, but for this demonstration, I thought it would be more clear to separate them. And so you see that I've clicked on the image and I've went over to the right-hand side and disabled the output. And now the software will ignore that image for the next job, and I'm just going to use it here to help align my through cut file. Back on the left-hand side, I'm going to click the image button again, and I'm going to import a DXF file. And this type of file has objects or paths within it that the software can recognize for creating through cuts. I'm going to drag this down over top of my rasterized image, zoom in and make sure that I have everything aligned. And then over on the right-hand side, I'm going to set my properties for my through cuts. I'm just going to be using the 3mm basswood plywood presets again in the cutting tab, and then I'm going to click the process button. In the preview screen, you'll see that just the through cut pattern is now displayed, and that's because I disabled the output of the engraving job, and then I can just hit framing again. Since I haven't moved the tool head or the workpiece since the last job finished, technically I really don't have to do this, but it is good practice. So I'm just going to skip over the part where I show you guys the framing, and I'm going to start the job now. Earlier I mentioned that in this example here, I'm going to be making these cuts with the workpiece directly on top of the silicone mat with no air gap in between. And obviously this is not ideal, but I'm doing this just to demonstrate that the silicone mat that I was telling you guys about can survive this type of abuse and save the table underneath. I've also sped this video clip up 3 times, and so in reality the tool head is moving quite slow, but you would have to expect this. Now the power setting is at 100%, but to cut through 3mm of wood, you're going to have to expose the wood to the laser for a longer period of time, hence the slower linear speed. With the through cuts, I would expect more smoke and fumes to be produced, especially considering the longer duration of time that the material is exposed to the laser. But again, with the extraction nozzle, I'm really not seeing any accumulation of smoke or fumes, so it's doing a very good job in this case as well. The cuts came out nice and clean despite not having the workpiece elevated off of the bottom mat. And the purpose of this thing that I made here was originally to test the kerf of this laser cutter. The kerf is the width of the cut produced by the laser beam itself, and some laser modules produce beam patterns that are not perfectly circular or perfectly square. When making things like jointed boxes that use these tab and slot type features to join panels, this could have an effect on the fit between the tabs and the slots. And so I've devised this sort of clearance test piece here where slots were cut in the X and Y direction, as well as a small little puzzle piece type feature here that has tabs on it cut in the X and Y direction. And this is going to allow me to get a better gauge on how the fit between the tabs and the slots is. And you can see that there's a scale where incrementally I've changed the clearance on those slots, starting from 0, which would be size on size, and then increasing with 0.1 millimeters and decreasing by 0.1 millimeters. By testing the puzzle piece tab in each of the slots and flipping it over to test in the both X and Y direction, I can determine whether or not I need to make any compensations in any one particular axis in my design. For the D1 Pro, I did not notice any difference in the X or Y direction, and the size on size setting seemed to work best. The negative 0.1 millimeter size was a very snug, slight interference fit, but I feel like when you start getting into bigger pieces with multiple tabs, you want just the tiniest amount of wiggle room to make sure that they all fit together. So I think I'm going to go size on size in the future. After calling this thing a kerf test, I did come to the realization that it's truly not a kerf test unless you've already compensated for factors that would influence the clearance for these tabs and slots. Off the top of my head, I can think of 3 things, and the first one would be the thickness of the wood. In this case, it's advertised as 3 millimeters, and when I measured it with a caliper, it's pretty darn close to 3 millimeters, so hopefully that's not having much of an effect. The second thing is the accuracy and repeatability of the motion system itself, and truthfully, I did not validate this in any way. Therefore, I'm trusting that it's reasonably accurate, at least within the realm of a tool at this price point. And the third and final thing that I can think of is how the software generates the toolpath. To my knowledge, XTOOL Creative Space cuts on the center of the lines within those files that you uploaded with the vector paths. If it was applying some sort of an offset and cutting inside or outside of those lines to compensate for the kerf, then of course that would also have an effect on the clearance and how you would need to design your clearances within the files that you're generating. With all of that said, I guess then it's probably more accurate to consider this piece a clearance test rather than a kerf test. However, kerf only has 4 letters and it just fits a lot better on this piece, so I did not change the name. And if you're looking for this test piece here, check the video description down below. I'll put a link to that where you can download this file for free. I'll give you guys a sneak peek into a future video where I've used the D1 Pro to cut out all these parts in this more complicated assembly, and I had used the results from that clearance test to create the design files for all of these parts. I'm happy to say that the fit was absolutely perfect, and if you guys are interested in finding out what this future project is all about, be sure to hit the subscribe button down below so you guys don't miss this next project of mine. In that video, I'm also going to reveal another easy and cheap upgrade for the D1 Pro, so you're not going to want to miss this. And to wrap this video up, I do just want to show you guys that the silicone mat did in fact save my table, and it can be easily cleaned up with a wet cloth and a vacuum cleaner. And once clean, you can see that the laser did not penetrate the mat, and flipping the mat over, you can see the table underneath is completely unscathed. To find one of these for yourself, check the links in the video description down below. So that's it for this video. I know it was a long one, so I really appreciate you guys sticking around right to the end, but I hope you guys decide to also come back if you're new to this channel, because XTOOL also sent me the RA2, which is the rotary attachment for this machine, and I'm gonna be covering that in another video. So hit the subscribe button so you guys don't miss that. And also don't forget to check out the video description where pretty much everything I've talked about in this video here, you'll find links to in the video description down below. And lastly, don't forget to check out my website, embracemaking.com, where you can support me and all of this work that I do to bring you guys this kind of content. Thanks for watching.